Inverse matrices and matrix equations, part 3. Okay, so we have looked at identity matrices. If I want to know if two matrices are inverses of one another, we multiply them together. If it's the identity that we get, yes, they're inverses. If I only have one matrix and I want to find the inverse, if it exists, then we can RREF. If we add on the identity matrix to the end, that was the long way. The fastest way is to put A in our calculator and then use the inverse button to find the inverse if it exists. Okay, so let's look at solving a matrix equation. Here, if I look at matrix A, matrix X, and that's equal to matrix B, if I have matrix A full of numerical entries, matrix B full of numerical entries, and I want to find matrix X, the variables of the system, what we can do is we can multiply both sides by the inverse. We just found out that if I multiply the matrix and the inverse by itself, we get the identity matrix. The identity matrix, remember, acts like 1 when I do matrix multiplication. So to solve for our variables, I'm going to find the inverse matrix. I'm going to multiply it by B, and that'll give us solutions to our system of equations. And that's all this is saying, is that I have a new way to find a new way to solve systems of equations. I don't have to use this. Our REF is still going to be our best option, but it's part of this section, so I'm going to show you how to do that section, this part of the section. Okay, so we want to solve a system of equations by converting to a matrix equation and solving the inverse. We're looking at converting to matrix form and then solving that inverse. Okay, so again, just a different way to solve. It's not mandatory, but we do want to look at how to use it. Okay, so what we could do is we could define an A matrix. That would be 5, 7, 4, 3, -1, 3, 6, 7, and 5. That would be our A matrix. Our variable matrix would be X, Y, Z. Now, why did I put this in that format as a 3 by 1? Remember, in order to do matrix multiplication, these two numbers had to match. And so I have to have a 3-row something, in this case 3-row 1 column. Okay, then we have our equal sign, and then we have a B matrix. The B matrix is 1, 1, 1. And if we remember our matrix multiplication, as long as these match, then I take these outside numbers, and the outside numbers is what the result would be. And that's what we get, a 3 by 1 matrix. Okay, so if it said solve the system, I would have just put this in augmented matrix form, RREF, and we're done. But it doesn't say that. It says solve the system by converting to a matrix equation, and then solve using the matrix equation. That's that one here. Okay, so to get that X matrix, we're going to take A inverse, if it exists. We're going to multiply it by B, and let's see what happens. Okay, so we're going to grab our calculator. Okay, let's clear that. We're going to go second, matrix, edit. We're going to need A inverse, so let's put in matrix A. Matrix A is here. Matrix A is a 3 by 3. We have 5, 7, 4. We have 3, -1, 3, and then we have 6, 7, 5. Okay, we'll look at matrix B. Matrix B is 3 rows, 1 column, and matrix B is 1, 1, 1. Okay, so we get back to the home screen. We clear everything out. Okay, so what we want to do is we want to take A inverse and multiply it by B. If the inverse exists, then we're going to get a solution to this system of equations. The solution is 8, negative 1, 8, negative 1, 8. So what we get is x is 8, y is negative 1, z is 8. Same thing we would have gotten using our REF. We're just looking at a different way to solve. We're looking at solving using inverses. Okay, let's try one more example. If it's just solve the system, we put into a matrix our REF and we're done. But it doesn't say that. It says solve the system by converting to a matrix equation. Okay, so we'll follow the directions. We have matrix A as 3, 2, 5, 4, negative 3, negative 2, negative 1, 1, 2. Matrix X are our variables. We're solving for X, Y, and Z. Matrix B is those numbers on the other side of the equal sign, 2, negative 5, 3, negative. And we want to use a matrix equation for solving. So we're going to use A inverse times B. Matrix X is equal to A inverse times B. Okay, so let's put in, we want to put in our A matrix, so second matrix, edit A. We have a 3 by 3 matrix. Putting in 3, 4, negative 1, 2, negative 3, 1, 5, negative 2, and 2. Okay, second quit, second matrix, edit B, 3 by 1, 2, negative 5, negative 3. Okay, so we have matrix A. We're going to double check that I put everything correctly into my matrix. Looks good. Matrix B. I'm going to check and make sure I put in the entries the way they should be. Looks okay. So now if I want to convert and solve the matrix equation, then I'm going to take matrix A inverse times matrix B. Matrix A times matrix B is equal to negative 1, 2, 3. So that tells us x is equal to negative 1, y is equal to 2, z equals 3. Now we only use this method because that's the method they wanted us to know and use. If the inverse doesn't exist, then you can get no or infinite solution. Then you have to go back to our REF. Our REF is always the easiest and the best way to solve a system of equations.